So welcome to another session of Everyday Mathematics. Today's problem is problem number 10 in the MIT 2024 integration B regular season, which is the definite integral from x equals to 0 to x equals to 10 of the floor function of x times the floor function of x. So this is a problem that involves nested floor function. Very interesting. Before we jump into the solution, like to thank our subscribers. Thank you so much for the support you're going to show us. We don't take that for granted. It is your support that motivates us to come here time and again. For first-time visitors, what we do at Everyday Mathematics is we go around and about and look for very interesting problems. We try and solve them. When we get solutions, we come back and share with you the problems that we think befit these problems. To our repeating visitors who haven't subscribed to our channel, we do really encourage you to subscribe to our channel. So this problem is interesting. The first thing that obviously we would like to just remind ourselves is what a floor function is. So if we have a variable x that is less than k plus 1, but also greater or equal than k, then it means that the floor function of x is k for the entire duration. And as soon as it falls, x falls between in the interval where it is greater or equal to k plus 1 and less than k plus 2, then the floor function of x now becomes k plus 1. So that means that now our integral of the floor function of x times the floor function of x from 0 to 10 is between 0 and 1, since the floor function of x there is 0, so it's 0 times x floor function. Between 1 and 2, since the floor function of x there is 1, so we have the floor function of x. And then between 2 and 3, since the floor function of x there is 2, so we have 2x floor function. And we keep adding until we get to the interval 9 to 10. The floor function of x within that interval is 9, so we have the floor function of 9x integrated in that interval. So since this is 0, so that collapses to 0, and now we have a summation of integrals from 1 to 2, floor function of x, 2 to 3, floor function of 2x, and so on up to the interval 9 to 10, where we have the floor function of 9x. So that can easily be represented as a summation from k equals to 1 to 9 of the integral from k to k plus 1 of the floor function of kx. So let's try to see what this integral looks like. So yeah, we do have interval k to k plus 1. And so at k, we have the value being k times k, which is k squared, right? And that continues all the way until when x equals to k and 1 over k, then that now shifts to k squared plus 1, right? Because k times k and 1 over k is k squared plus 1, right? And then so it continues in that at that value up to when k is x equals to k and 2 over k, and at that point it transitions to k squared plus 2 and so on until now we come to k and 9 over k and k minus 1 over k. At that point we have k squared plus k minus 1, and that continues until when x equals to k plus 1, and then it transitions to k squared plus k. But this is what happens. And so the integral now means that since the spacing here is 1 over k, 1 over k, 1 over k, so we have k squared times 1 over k, and here we have k squared plus 1 times 1 over k. Let me just represent this nicely. So we have this rectangle here, which has the height k squared and the width 1 over k. And then we have this other rectangle, we have the height k squared plus 1, but the width still remains 1 over k. and then so on, right? And then, you know, keep doing that. So that until we have this last rectangle where we have k squared plus k minus 1 times 1 over k. So this is how you're going to represent it. And so essentially what happens here is that now we do have a summation or from k equals to 1 to 9. And in there we have now different strips within the interval of k. We have now the width 1 over k times k squared plus L. So where L now straddles between 0 and k minus 1. So, you know, when L is equals to 0, we have k squared times 1 over k. When L is equals to 1, it's k squared plus 1. And L is equals to k squared plus 2, and so on until we come to k minus 1. So this summation here, when L is equals to 0, we have 1 over k times k squared, and then plus the summation from L equals to 1 to k minus 1, right? And that means that we're keeping this 1 over k times k squared plus 1 over k. This k in this summation is a constant, so we just now have k squared times k times 1 plus this L here using your arithmetic progression is, so the summation of L from L is equals to 1 to n is the same as n over 2 times n plus 1, right? And so n here is k minus 1, which is here. N plus 1 is k all over 2. That's what we've done here, right? And so we continue by saying now this is 1 over k because we pulled out 1 over k, this 1 over k and this 1 over k out. And we have now k squared plus k squared times k is k cubed minus k squared times this negative 1 is minus k squared plus k squared minus k over 2. 1 over k, so we multiply 2 across, and then we have it all divided by 2. So we have this cancel with that, and so we have 2k cubed plus k squared minus k. And this, we can pull this half out so that we have 1 over 2 out, summation of this k divided by this k cubed, which results into k squared. This goes away, and then this goes away, and we are left with 1 here. So we have 2k squared plus k minus 1. So we now have our integral being equal to a half times the summation from k equals to 1 to 9 of 2k squared plus k minus 1. And now just the popular things that you could know from heart. Summation from k equals to 1 to n of k squared is the same as n times n plus 1 times 2n plus 1 over 6. The summation of k from k equals to 1 to n is n times n plus 1 over 2. So we can plug this in here with n being equal to 9. And so for this k squared, we have 2. And in place of n, we have 9. In place of n plus 1 is 10. In place of 2n plus 1 is 2 times 9 plus 1, which is obviously 19. And then for this k, we have n is 9, n plus 1 is 10, all divided by 2. So this 2 divided by 6 is 3, and then the 3 and 9 we have 3. So, and then this 2, and we have 5 here, right? So we have a half, 3 times 10 times 19, plus 9 times 5 minus 9. And here, this is the same as pull 9 out, 5 minus 1, yeah, from this set of which is 9 times 4, right? Ooh. So we have a half, 3 times 10 times 19 plus 9 times 4. And now this is 30 times 19, which is 570. 9 times 4 is 36, which is a half times 606, which is equals to 303. And this is the final answer for this problem. Certainly a very interesting integral, but I hope you're able to follow along. If you have any questions, please feel free to leave us a question or a comment. We'll be very glad to get back to you. Certainly would like to interact with you and just start a conversation. I would love to learn from you as well. If you have any suggestions, we're very much open to hearing from you. Well, until next time, it was an absolute pleasure solving this problem and giving you a version of what we think is an answer or a method that could lead to an answer that is interesting. Other than that, until next time, bye bye. See you.